Alright, hello. Well, this is a video for Unit 4, Day 26. Now, yesterday I might have skipped, I think we did Day 24 yesterday, so make sure you're on the homework, you're looking at the right homework. If I skipped over Day 25, I'm going to teach that tomorrow, but today is Day 26. So hopefully you have a piece of paper for notes. In a few minutes, I'm going to be doing an application question that looks like this page. So you can just have that off to the side for a second. Hopefully you've got that handed out already. But for now, you just need a blank sheet of paper. And you can label the top Unit 4, Day 26. And this is called the Law of Cosines. Now, yesterday we did Law of Sines, and some of you might have heard of these last year, but if you didn't, it's pretty easy to use. It's basically ways to find different sides of a triangle. So here's a triangle, and let's say I label it A, B, C. So if that's angle A, this would be little a, this would be little b, this would be little c. And yesterday, if you remember, when can you use Law of Sines? The Law of Sines is for when you have a complete ratio. So like when you have a side and the angle across, as long as you have some kind of complete ratio like that, you can use Law of Sines. But there'll be plenty of times when you can't use Law of Sines. And Law of Cosines, let me just write out the formula first, is a squared equals b squared plus c squared minus 2bc cosine a. Now that's the formula. Don't get too attached to the letters because it doesn't have to be a squared on the left. It could be b or c depending on what side you're looking for. But what's actually important is that this is some angle. And again, it can be any angle. It doesn't have to be a. That's just an example. But since this is little a and this is big A, this means that this has to be the side across from angle. So that means whatever angle you use over here, you have to use the side across from it and put that over here. Now B and C, which are the same in all those spots, so they're just the other two sides. So in other words, it's the sides that aren't across from that angle. And we can use this when we don't have a complete ratio. Law of Sines is generally a little bit easier to use and set up. So if we have the option, we use Law of Sines. So I'm just going to say down here, use when you don't have a complete ratio. So in other words, use when you can't use Law of Sines. Okay. Now the first part of your homework tonight is a little vague. It's just going to say solve the following triangles. And what solve the following triangles means is find any missing side and angle. So you'll see in tonight's homework that you'll get a few pieces of information, like for this one, if I told you that A was 41.4 degrees, little b is 2.78 yards, and little c is 3.92 yards. That's all the information they give you, and they expect you to just find all the other missing sides. Now you can use Law of Cosines or Law of Sines to do that depending on the situation. Okay, so first thing you want to do definitely is draw out your triangle. Let's see if I can get a different color here. Nope, black it is. Okay, so here's A, B, and C. And A is 41.4. Across from B, we've got that 2.78. Across from C, we've got that 3.92. So we've got to find angle B, angle C, and this side here. So, do you have a complete ratio? I only have one angle here. I don't have the side across from it. So no, I don't have a complete ratio. So I have to use law of cosines. Now, based off of law of cosines, this is the only angle I have right here. So if I only have this angle, then I have to get this side to the left of the equal sign. So setting up law of cosines, you're going to have a squared equals the other two sides, so 3.92 squared plus 2.78 squared minus 2 times 3.92 times 2.78 times the cosine of 41.4. Now this way, law of cosines is pretty straightforward because all of this over here is a number. So you can plug all of this in your calculator in one step, and that's what I would suggest you do. You also want to make sure you're in the right mode. We got to be in degree mode because of this 41.4 right over here. So here's my calculator, and make sure your mode, I'm in degrees. Okay, so I'm just going to type this in all in one step. So 3.92 squared plus parentheses 2.78 squared minus 2 times 3.92 times 2.78 times cosine of 41.4. And that will give you big long decimal 6.74. Remember, that's what a squared is equal to. So don't round yet. We've got a squared equals 6.7459 dot dot dot. And to actually find side A, I got to take the square root. So back to our calculator, if I do square root of the answer, I get, and we'll stay consistent, these are all to the nearest tenth, so about 2.60. So A is about equal to 2.60 yards technically. Okay, so now I've got this side. So now I have to find one of these other angles. So I guess might as well just find this angle here next. So now using this 2.60, I can use law of sines. So I could set up, let's see, myself a little more room here. We could say 2.60 over the sine of 41.4 equals 2.78 over sine of A. Now there is a little problem with what I'm doing. I'm using a rounded answer right here, which really isn't going to give me the best possible solution. I really should use this big long number, and when I do my calculator work, I'm going to do that. So just as a side note, I'm really using that 0.59 dot 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 number here. Okay, so law of sines would say take 2.78 sine of 41.4 and divide it by that answer. So I'm just going to say second answer. And that'll be that number there. So now I'm not getting a rounded answer. So sine of A is equal to that. Go back here for a second. Sine of A equals 0.707 dot dot dot. And if I want to get A, I've got to do the inverse. So A equals sine inverse of 0.707. And when I do that, so second sine of that answer gives me 45.05. And again, we'll just say consistent. This was to the nearest tenth. So 45.05 would be about 45.1 degrees. Okay, so that's A. Now the last thing I got to do is find C, and at that point this should be easy because if I know these two angles, what do I know about three angles in a triangle? They add to 180. Okay, so I can just come over here and say angle C is going to equal 180 minus 41.4 minus, use that non-rounded answer again to get your most accurate answer. So here in my calculator, 180 minus 41.4 minus that answer, so second answer again, gives me 93.5. So C is equal to 93.5 degrees. degrees. Okay, so really we only had to use law of cosines for that first step, but that's what solve the triangles means. So when you see the homework questions say solve the triangles, they mean find any side or angle that's not listed. Any questions yet? Hopefully not. Okay, now there is another way to use law of cosines. So in this next example, I don't want to spend the time solving the whole triangle, so I'm just going to ask you for a specific side this time. I'm going to tell you that little b is 28 feet, little c is 47 feet, and little a is 58 feet. I'm going to specifically say find angle B. Okay, well definitely first thing we want to do is draw out our triangles. So here's your triangle. Label it A, B, C. Across from B is 28. Across from C is 47. And across from A is 58. I'm looking to find angle B. Okay, now I can't use law of sines, and that should be fairly obvious because, why? Because there's no complete ratio. I need an angle and a side, and if I just have three sides with no angles, there's no way I have a complete ratio. So I got to use law of cosines. Now think about it. If I want to find angle B up here, which one of these three sides is going to have to go left of the equal sign in my cosine equation? Well, since I'm finding angle B, side B has to go over here. So 28. So it's going to be 28 squared equals 47 squared plus 58 squared minus 2 times 47 times 58 cosine of B. So that's why I said don't get too attached to the letters, because it's just based off of whatever angle's going here. The side across from that has to go here. Okay, now this time, this is the variable. That's the piece I'm trying to solve for. So I can't just plug this all in. And the common mistake people will make is they'll plug in this part of it all in one step. But what's wrong with that? Well, the 47 and the 58 squared, those are off on their own. Those can be combined. But this 2 times 47 times 58 is attached to cosine of B. It's just like if you had 7 minus 5x, well, you know that's not equal to 2x. You can't combine the 7 and the 5 and tack it on with the x there. Same thing goes here. You can't combine these and then tack it on with the cosine of B. So what we have to do is do this in stages. So 28 squared we can definitely type in. So 28 squared is 784. So I get 784 equals. Now these two pieces aren't attached to anything, so those two I can combine also. So I'm going to do 47 squared plus 58 squared. 5573. And I can multiply these to at least make it one number. 2 times 47 times 58. 5452. Times cosine of B. Remember, I'm solving for this cosine of B right here. So I'm going to subtract this 5573 over. So 784 minus 5573 gives me negative 4789 equals negative 5452 cosine of B. I'm going to divide by negative 5452. And that also should give me a big ugly decimal divided by negative 5452.878 dot dot dot. And like usual, if I want to solve for the actual angle, I've got to do second cosine. So angle B is going to equal cosine of inverse of that big 0.878 number. Remember, it's important not to round it. It's going to throw off your answers. The second cosine of that answer is 28.55. And since all the other measurements so far are to the nearest whole number, we'll stay consistent and say this is about equal to 29 degrees. Okay, so that's another way to use law of cosines. When you're solving for an angle, it's a little trickier than just plugging it in one step, so be careful about that moving around. Okay? Now, on the homework, if this had asked you to solve for the following triangles, you'd still have to find these other two angles. You could use law of cosines again, and then subtract from 180, or you could even use law of sines now, using this complete ratio that you got. But for now, we'll just leave it at that. Okay, one more question for your own notes, and then we'll go on to that application question. Find the area of the triangle with sides 42.5, 37.0, and 28.5. Okay, now this is a question from a couple days ago. Find the area. So remember the area formulas, we've got a couple options. So let's just draw this out, see what we've got here. They didn't really say anything except just what the sides are. So this is 42.5. We'll call this 28.5. Call this 37.0. Doesn't really matter. And I'm looking for the area. Now, if you remember, there were two area formulas. There was area equals 1/2 AB sine C. And there's also Hero or Heron's formula, which is area equals the square root of S times S minus A times S minus B times S minus C. You remember what S is? S is half the perimeter. Okay, so clearly, given this setup, what's the better formula to use? Heron's, because I know that I just know the three sides, so we could find S pretty quickly here. Let's do that. So we'd have half of the perimeter, which is 42.5 plus 28.5 plus 37. So S is 54. So that means the area would just be the square root of 54 times 54 minus 42.5 times 54 minus 28.5 times 54 minus 37. And then I go to my calculator again. Square root of 54 times 54 minus 42.5 times 54 minus 28.5 times 54 minus 37. And that gives me an area of about 518, we'll say 0.8 because everything else is the nearest tenth. 518.8, and there's no units. So actually we'll call it meters. So meters squared. Okay, and that's all fine and good as long as you remember this formula. But let's say you panic on the test and you don't remember this formula. The only formula you know is this one. Why can't I use this setup with this formula right now? Because I need an angle. I need an angle C. I have three sides. Is there a way to find an angle? Sure, I just got to use law of cosines now. So pick your favorite angle, doesn't matter at all. Let's say I decided to find that angle. Then if I'm finding this angle, we'll call that X. Then what side has to go across from the equal sign in the law of cosine formula? Got to be 37. So it would be 37 squared equals 42.5 squared minus 28.5 squared minus 2 times 42.5 times 28.5 cosine of X. So is this one that I can plug in one step, or do I have to be careful and move stuff around? So I'm solving for cosine of X, I got to move stuff around. Oops, sorry about that. Okay, so let's do what I can do here. I can do 37 squared, which is 1369. I can add 42.5 squared and 28.5 squared. is 2,618.5. That should be a pen of plus here. I can multiply those numbers together. So 2 times 42.5 times 28.5 is 2422.5. Now I have to move this 2618 over. So 1369 minus 2618.5 gives me negative 1249.5 equals negative 2422.5 cosine of x. And I have to divide that over. So divided by negative 2422.5 gives me 0.5157 equals cosine of x. And finally, to get my angle x, we got to do that inverse cosine of 0.5157. So I'm going to do second cosine of the answer, so I'm not using a rounded answer, 58.94. Why am I just saying dot, dot, dot and not rounding this part? Because that's not my final answer either. I needed this angle so that I could use this area formula, because that was my final goal. So now that I know this angle, I can use this formula. What sides have to be A and B? Remember, in the area formula, whatever angle you use, these have to be the sides surrounding it. So I got to use 42.5 and 28.5. So I'm just going to come over here. Area is equal to 1/2 times 42.5 times 28.5 times cosine, or sorry, it's area formula. So it's sine of 58.94 dot dot dot. I'm not rounding that yet. So 0.5 times 42.5 times 28.5 times sine of my answer from here, so second answer. What do you know? Same exact answer that Heron's formula gave us. 518.8 meters squared. Okay, so why did I take you through all that? Obviously, it's way, way simpler to use Heron's formula there. But you all know that you get that point in a test where you might not remember a certain formula, and just know that you have other options. Okay, hopefully that makes sense. Last thing I want to do here is go through that application question, because there's one like that in the homework too. So if you can, switch over to that sheet that looks like that. And go ahead and read through that. A surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. While standing at point C, she finds that AC is 259 meters, BC is 423 meters, and angle ACB measures 132 degrees and 40 minutes. Find the distance AB. Okay, so we've got some lake. There's my lake. And there's 2 points on opposite sides of it. So there's A, there's B. Apparently you can't get to those points. But a point that she can get to, call C, she finds that AC is 259 meters and BC is 423 meters. And she knows that this angle here is 132 degrees 40 minutes. She wants you to find this distance that I can't measure because I can't get to those two pieces. Okay, so we got a triangle clearly. Is it a law of sines or a law of cosines situation? Hopefully you're saying cosines. Why is it cosines and not sine? Well, because you can't, I'm looking for this side here. I have one angle, I don't have the side across, so I don't have a complete ratio. So if this is the angle I'm using, what's got to go to the left of the equal sign? The side across is x. So we're going to have x squared equals 259 squared plus 423 squared minus 2 times 259 times 423, that's 9 there, cosine of 132 degrees, 40 minutes. Now, is this one that I can type in all in one step or not all in one step? I can do it all in one step. Okay, so I can do 259 squared plus 423 squared minus 2 times 259 times 423 times cosine of 132 degrees, gotta go second apps, 40 minutes, second apps again, gives me that big number. So x squared equals 394,510.56 dot dot dot. We take the square root. So square root of that answer gets us 628. And the other distances to the nearest whole meter, so we'll say about 628 meters. Okay, so that should be enough to do your homework, which is listed on the back board. Remember, I skipped over day 25 temporarily, so you're looking at day 26 for your homework. So day 26, not day 25. And I'm not sure what time's looking like. I know we're on shortened periods today, but if you do have some more time, I don't want to deprive you of today's warm-up, which would have been this. And there's your random fact of the day down there. But I wanted to talk about this because we went over this quickly yesterday. There were some homework questions on angle of depression. I want to make sure you're all solid drawing that. So if you got some extra time, if the time period's not up yet, read through this. Just at least the setup. A pilot approaching a 10,000 foot runway finds that the angle of depression at the ends of the runway are 17 and 12.5. How high is his plane and how far is it from the near end of the runway? So you've got some plane up here. And they're approaching a runway. And the runway is 10,000 feet long. Angle of depression. So angle of depression is when you're looking straight out and then down. And he's got two views at the ends of the runway. So the angle of depression, this one would be the smaller angle, 12.5. This one would be the bigger one, which is 17.0. We want to know how high his plane is. And we also want to know how far to the near end of the runway. So that'd be this distance there. So it's a double triangle problem. Now when you have angles listed up here, remember these two lines, this dotted line and this ground here, are parallel. So we've got alternate interior angles here and here. So this is also 12.5. And we can figure out what this piece of this angle is just by subtracting these two. Right? So if I did 17 minus 12.5, 4.5. And then I could find this angle by taking those two and subtracting from 180. So 180 minus 12.5 minus 4.5. That's 163 degrees right there. And then I can find this angle by subtracting 163 from 180. So 17. That's a right angle because it's straight down to the ground. And finally subtract this side from 180. So 180 minus 90 minus 17, and you got 73. So that happens a lot in double triangle problems. Let me take this out because that's not used anymore. You can find all the angles. So now the side that I'm going to find first is this concluded side. And what would you use to do it? Hopefully law of sines. You do 10,000 over sine of 4.5 equals x over sine of 12.5. And we'd go from there. Okay, so I think time's probably almost up. I just wanted to at least show you a setup. Angle of depression, use alternate interiors. That's not going to come up on tonight's homework, but that will in the future again. Hope this made sense today. If it doesn't, you can always go to my website and rewatch it later today. But good luck on the homework, and I will see you back at school.